here we would like to talk about the definition of symmetries. In this class we will talk about 3 different symmetries. The first is symmetry about the x-axis, and I have drawn an example of a graph that is symmetric about the x-axis. Symmetry about the x-axis means that if you cut the graph along the x-axis, then you can fold one side of the graph over onto the other side of the graph and have it exactly match up. Consider for a minute a point on my graph. Let's say that this ordered pair is 4, 2. For every point, there also must correspond a like point across the x-axis, and the thing that makes it symmetric is the form of that ordered pair. Notice here that our x value wouldn't change, so the x value would remain the same at 4. But then the y value would be the opposite of the y value in the other ordered pair. So a relation is said to be symmetric about the x-axis if for every point xy on the graph there also exists a point with the same x but an opposite y value. In the next piece, we're talking about symmetry about the y-axis. That means that if you were going to cut your graph along the y-axis and fold the graph, then one side would perfectly match up with the other side. Here is an example of a graph that's symmetric by the y-axis. Let's look at an ordered pair. Let's say this ordered pair is 2, 2. Then we would have to have an ordered pair across the y-axis that would perfectly correspond with that ordered pair 2, 2. Let's think about what that ordered pair would be. We can see here that our x value would have to be the opposite, so it would have to be -2. But the y value remained the same, +2. So a relation is said to be symmetric about the y-axis if for every point xy on the graph there also exists a point with a negative of the x value and the same y value. If a relation is symmetric about the y-axis, it is called even. Make sure that in your notes this says y-axis. There had been an error before. Make sure that says y-axis. But symmetry about the y-axis and even means the same thing. A relation is said to be symmetric about the origin. So on this particular example, this is symmetric about the origin. And the way we can tell is if we look at the ordered pair 0, 0 and then go to another point on our graph, there has to be another point equal distance through the origin on the other side of my graph. So let's say that we label these ordered pairs. Let's say that this is 2, 8. Then what would this other point that corresponds have to be? Well, we notice it's in the third quadrant. That means that both of these would have to be negative, so it would be -2, -8. So for a relation to be symmetric about the origin, then for every point xy on the graph, there has to exist an opposite point, so -x, -y. If a relation is symmetric about the origin, then it is also called odd.